Okay, so let's continue. And I just see a question in the group chat. You see that how can we set up DHCP server can serve more than 253 IPs? Okay, so let's see it first. Before we go to the next part, let's see it first. Just now we said that if for example, if the subnet is 192.168.1.0 maybe slash 24, the mask length is 24. The reason why we only have 253 available IPs in this subnet is that totally actually the IP address is 32-bit length, right? And the last part, since the mask length is 24, so we only have 8 bits, right? 8 bits for the subnet. We call it the host part, right? Host address. For example, 1.1, 1.2, 1.3. And the reason the number is 253 is that 8 bits means we have 256, right? 256 IP address in this subnet. But for the network, for the IP address 192.168.1.0 and 1.255, these two IP address cannot be assigned to clients because 1.0 is the network address, 1.255 is the broadcast address. And except that 1.254 is the IP address of the gateway, it should be reserved. So 256 minus 3, we only have 253 IP address. And if you want to have more IP address right, in this subnet, so you can make the mask length to be maybe shorter. For example, 192.168.0.0/16. 16 means the first 16 bits is the network address, and the last 16 bits is the the host address. So in this case, you have about 2 times 8 and minus 2. You have a lot of IP address can use. So about your question, how can we get more than 253 IP? It's just to use the larger subnet, okay? To use a larger subnet. This is the content we introduced in the RCNA RS, right? So if you are still yeah, you noted, right? Okay. And you can check some detailed information in that course. Okay, you can watch some videos maybe. Okay, after solving this problem, then let's go to the next part. Next, actually at here we have introduced the roaming, right? The roaming of STAs. And another scenario is that the AC is 40. It will affecting the service of the terminal. It represents that sorry for that. Okay, let's go. Now, in the left figure, you can see we have AC. We have AC, and the AC will establish the capital terminal between each AP. And there could be a problem. There could be a problem is that if the AC is 40, actually all the APs will go offline, and all the STAs, pay attention here, all the STAs will lose the connection. Okay, will lose the connection, and they cannot access the network anymore. The service is interrupted. Okay, so to avoid this kind of fault in the network, what we can do, or in other words, to improve the reliability of the WLAN, what we can do, we can use the AC hot backup. Okay, what we can use is AC hot backup. Okay, and let's see how that works. Now we have two ACs, AC1 and AC2. To do the AC hot backup, we should have two ACs. Okay, and then AC1 and AC2 will establish AC hot backup group. Okay, hot backup group, and AC1 and 2 works in the same group. In this case, AC1 and AC2, they will do an election. After the election, they will determine, for example, AC1 is a master. AC2 is a slave. Okay, and between the AC and APs, since we have two APs here, they will establish the kappa terminal. So you should know AP will establish the kappa terminal between the master AC and the AP will establish the kappa terminal with the master AC, and at the same time, it will also establish the terminal with the slave AC. And the kappa terminal between AP and the master AC, we call it the active. We call it active kappa terminal, and this is the backup. Okay, this is a backup kappa terminal. And normally, all the traffic will go through the active one. Okay, will go through the active one. And when the AC1 is 40, when AC1 is 40, so we will switch to the other AC, AC2. And between AC1 and AC2, they will establish a connection to, the function of this connection is to keep alive. Or in other words, is to monitor, right? Through this connection, AC1 and AC2 will monitor each other, monitor the running status of each other. They will exchange some messages. Okay, so this is the way, how do we improve the reliability of the WLAN by using the AC hot backup. And for the AC hot backup, actually we have two different modes. Let's see. The first is the AS mode.
It's working pretty simple. So let's start with have intricate.
Okay. We have two modes, AS mode and AA mode. Let's see what's the difference between them. AS mode means one of the AC is the active AC. Okay, one is active. So A and S means standby. Okay. Okay, that's it. Now AC1 is a master, AC2 is a slave. This is a result of the election, right? Okay, this is the result of the election. And if we use the AS mode, AC1 is a master. So all the APs will establish the kappa terminal with AC1, and all these terminals are active kappa terminal. Okay, active kappa terminal. And since AC2 is the slave AC, so all the terminals between AC and the AC2 and the APs are standby kappa terminal. And in this way, all the how can I say? In the centralized forwarding mode, all the traffic will be forwarded to AC1, and AC1 will manage all the APs. Okay, and while at the same time, AC2 is free, is standby, is totally free, and it will not forward any traffic, it will not control any APs. So we think that the AS mode is not that good because the results of AC has been wasted, right? The results of AC2 of the slave AC has been wasted because it do not operate any things. So we can use the second mode, AA mode. AA mode means the no matter AC1 or AC2, both of them are active or are master. You can see AC1 is a master, AC2 is a master. But pay attention here. The reason why both of them are master is that, for example, AC1 is managing AP1, AC2 is managing AP2. So for AP1, it thinks that, okay, AC1 is a master, but AC2 is a slave. Let's change the color. Okay, AC1 is a master and AC2, this is the standby. And for AP2 is the same. For AP2, AC1 is the master, while AC1 is the backup or the standby AC. Okay. And I see questions is AC hot backup in the AA mode when AC1 had got down, the all APs on AC1 moves to AC2. Yes, yes. Actually, you can think it's similar to the VRP. It's similar to the ARP. In the ARP, we think if we have two routers, and after using ARP, one is a master, one is a slave. So all the traffic will go through the master, and the slave is free. So we can maybe create two VRP groups. And in VRP group 1, router 1 is a master. In ARP group 2, router 2 is a master. And at the same time, they are the backup of each other. Right? So obviously, if AC1 is down, all the APs managed by AC1 will move to AC2. They are also the backup of each other. Okay. This is the AC hot backup, which can be used to improve the reliability of the network. And then let's see, how do we determine which AC is the master, which AC is the slave? Okay, let's see it. Firstly, if neither AC is running hot backup, means, for example, now we didn't enable hot backup on both ACs. So in this situation, firstly, we will compare the priority. You can see AC with lower priority is a master. With lower priority is a master. While if the priority of them is the same, then AC with lower MAC address is a master. So when we do the election, when we compare the parameters, we should know that the parameter or the value of the parameter is the lower the better. Okay, the lower the better. While if one of the ACs is running hot backup, okay, for example, if we have already enabled the hot backup on one of the ACs, in this case, the AC which is running hot backup is the master. It says that if one of the ACs is running hot backup, so the AC which is already running hot backup will be the master. While if both of the ACs are running hot backup, what we will compare is the number of APs. The AC connecting with more APs is a master. Okay, because if both of the ACs are running hot backup, and then after election, one of them will be the slave, right? Will be the standby AC, and the APs which is connected to this AC will switch to the other one. So the reason why we prefer AC is connecting with more APs is a master, because if the ACs with more APs is a master, so we have fewer APs, right? Fewer APs should switch to the other AC. It will cause maybe less effect to the network. Okay, so this is the master election rule of the AC hot backup. And actually, except the AC hot backup, we still have some other technologies which can be used to improve the reliability. For example, we can use virtual AC. Right, we can use virtual AC, or we can use AC cluster. Okay. Okay. But in this case, we we just introduced the AC hot backup, which is used maybe more frequently than the other two technologies. Okay, and then let's go. Is the scenario 3 to prevent unauthorized users from accessing the network. Actually, to prevent the unauthorized users for accessing the network, what we should do is to enable the authentication. Right? How do we verify if they are authorized or not? Right? If they can pass the authentication, we think they are authorized. If they cannot, so they are unauthorized. And then, if the STA want to associate with the AP, the first step is to scan. Is scanning. Scanning means, for example, you now when you use your mobile and you turn on the WLAN function on your mobile, it will automatically scan the signals, and then you will get a list. In this list are the SSIDs. Right? This is the scanning. And then next is authentication. If you find, for example, if you find the WLAN you want to connect, so you will click it, and then sometimes it is open. Open means you don't need to authenticate. But for most of the WLANs, you should do some actions to authenticate. For example, you should enter the password, or you should maybe you should finish the authentication on a web page, or even you should use the client software, right? Or client application to do the authentication, right? And once you pass the authentication, your next step is the association. You will associate with the AP, and then is the data receiving, data forwarding, and is the transmitting of data. And to prevent the unauthorized users accessing the network, what we should do is to enable some authentications. And for the authentications, we have, you can see here, we have 802.1x. Okay, 802.1x authentication. We have MAC authentication, web authentication, and except that, we have more, for example, open authentication, or even or open authentication is also called non-authentication. It is totally open, and you can directly connect to it. And except that we still have a PSK, pre-shared key authentication. Pre-shared key means you should configure the key of the network, and for the users, they should enter the key they have, the password they have, and then they can access the network. Okay. Since the open and the PSK authentication is simple, so here we just compare the difference between these three types of authentication. For the 802.1x authentication, if you use it, firstly, if you want to enable it in the network, you should have a server to support the 802.1x authentication function. And for the STAs, or for the terminals, you should install an application, okay, or you should install a software on your, no matter laptop or on your mobile. And then if you want to access the network, you should enter the username and the password in this software, so you can maybe pass the authentication and access the network. Okay, so you can see here, actually, yes means we need a client, we need a software. The advantage of it is that it has a high security. It has higher security. And the disadvantage is the deployment is not flexible. So it's more suitable for some, for example, for some scenarios that we should, if we want to access the company's network. Right? For example, the internal network of a company, so it's better to use the 802.1x. It's more secure, and for the employees, it's not that difficult for them to install software, because they need to use it every day. So it's not that convenient, not that inconvenient. Sorry. And next, the MAC authentication. MAC authentication means the authentication is based on the MAC address. Only the devices with specific MAC address can access the network. Okay, and the MAC authentication do not need any clients, right? This is the advantage of it. While the disadvantage is that need for MAC address registration and complex management is more suitable for some terminals like maybe the for example, the printers, right? The printers or maybe some cameras in the network to use the MAC authentication. And next is the web authentication. Web authentication is also mentioned as the portal authentication. We should do the authentication via a web page. In this web page, you can use your username and password, or you can use the message code. You can enter your phone number and you can get a message. You can use a code in the message to log in, or we have different methods. This is the web authentication, and the deployment of web authentication is flexible, but disadvantage is that it's not that secure. Not that secure. It's more suitable for some maybe guest networks. Guest networks in maybe in some office, in some shopping malls, in some public areas. That do not need high security, but just need the authentication. And there it has another advantage is that because you should log in through a web page. So on this web page, you could have some words, you could have some pictures. So maybe we can design a web page. In this web page, it could contain some commercial, maybe advertisements. So we can maybe get some benefit from it, right? Okay, so this is about the authentication. And next scenario is the wireless STAs are not allowed to access each other. This kind of requirement is also commonly found for some public networks. For example, for the guest Wi-Fi of a company, there could be different kind of maybe customers or some different types of users access this guest Wi-Fi. So to ensure that the users of this Wi-Fi will not be affected by other users, so we should isolate, or we prefer to isolate each user in which is associated with this WLAN. And what we can use is the user isolation. And the user isolation can be divided into different types. Let's see. First is the AC-based user isolation. If you use the AC-based user isolation, users served by different APs connected to the same AC cannot access each other. Okay, and AP-based means users served by the same AP cannot access it with each other. And AC SSID based, let's see, users on the same WLAN. Pay attention, same WLAN means the SSID, right? SSID is the same. And of different APs connected to the same AC cannot access each other. This is the AC SSID based. And AP SSID, from the name, we can know that users on the same WLAN, and of an AP. Of an AP means same AP cannot access each other. So from here, we can know we have different types of user isolation, and you should determine which type you prefer in your network based on the network architecture. Okay. And then once we enabled the user isolation, all the users associated with this WLAN is associated. But if we have some special requirements, for example, one of all these users, maybe one or some of these users should not be isolated. So there is a permit list, another function. we can configure permit list and add some of the users or some of the STAs to this permit list. And the users in this permit list are not limited, are not isolated. They can maybe access each other, or they can access other devices. They are not isolated. Okay, this is about the user installation, which can be used to improve the security of the network. And to improve the security of the network, we still have another method. The method is called the whitelist and the blacklist. Let's see it. Whitelist means the STAs not in the whitelist cannot access the WLAN. Or in other words, if you are in, for example, if you are in the whitelist, you are allowed to access. But if you are not in the whitelist, you are not allowed to access the WLAN. And for the blacklist, it's similar. Blacklist means the STAs in the blacklist are not allowed, but the STAs not in the blacklist are allowed to access. But if we only configure the whitelist or blacklist, it's a kind of global configuration. It will affect all the WLANs. If on maybe on AP we have two SSIDs, so the blacklist and the whitelist will take effect to both of the APs, sorry, to both of the SSIDs, both of the WLANs. But if you only want, for example, if you only want to enable it for one specific SSID, so you can use the whitelist based on SSIDs or blacklist based on SSIDs. So in this way, you can maybe specify which SSID you want to enable this blacklist or whitelist. Okay, and here is the configuration command you can see. Okay, WIDS, we should enter the configuration of WIDS, and this is the configuration of the whitelist based on SSIDs. SSID filter, whitelist, MAC address. MAC address means the MAC address of the STA you want to add to the whitelist here, and in which SSID. So here is to specify the SSID you want to use it in SSID test. And for the blacklist is similar, right? What we should change just change the blacklist into whitelist, and at the same time you can also adjust the number of STAs contained in the blacklist. Here we change it to be 100, right? And the number of the limitation here is from 1 to 128. Okay. Okay, this is about the access control for specific terminals. Okay, and this is all the this is all the technical contents we want to share at this part. And I think that after finishing these parts, you can have a deep understanding of the contents in the RCNA WLAN. Okay. Please send over our presentation to us too. Okay, no problem. We have recorded the training, and we will upload. Okay, we will upload the record of the training and all the slides I use to the e-learning, and at the same time we will share with you. Okay, you can get all these contents. Okay, after finishing the lecture parts, next let's go on. Since I think you still remember that we still have a lab, right? So let's see the lab together. Okay, so let's see. In this lab, we have two switches, one AC and two APs. Right? The architecture is quite simple, right? Well, let's see how to finish the configuration of this topology step by step. Okay, first is the basic configuration. we hope that after the basic configuration, we can establish the connection. Okay, establish the communication between each device. For example, you can see on the core switch, we should create some VLANs, VLAN 10, 20, 30, 40. And here, let me introduce it. VLAN 10 is a VLAN for, actually in this network, we have two SSIDs. The first is the employee, okay? VLAN 10 is a VLAN for the WLAN, which SSID is employee. VLAN 20 is that of the SSID guest. VLAN 30 is the VLAN for all the APs, and the VLAN 40 is the VLAN we use between AC and the switch, because here is a layer 3 connection, okay, layer 3 interconnection. So we should have a interconnection address, okay, interconnection address for AC and the core switch. Okay, and on the AC, we have a loopback interface 1.1.1.1, and we plan to use this IP to establish the CapWeb kernel. And VLAN 40 is the interconnection address between AC and the core switch. And on both core switch here, on both core switch and the AC, since it's a layer 3 interconnection, so we should have some routes. And what we use here is the static route. By using these two static routes, we can establish the communication between the AP and the AC, because 1.1.1.1 is the AC. 192.168.30.0 is the subnet of AP. Okay, so this is the what we should do during the basic configuration. And then let's see it. Let's see the configuration of the, let's see the basic configuration. Okay. Since for the WLAN, we don't have the simulator, we should use the real device. Right? We should use a real device, so it's not that convenient to use the real device here in the meeting room. So I just record the video of the configuration, and let's see it together. Okay, firstly, here I'm changing the name of the switch, right, by using the command hostname core switch. And next, I'm creating VLANs. Right? We have VLAN 10, VLAN 20, VLAN 30. You can see by use the command show VLAN, we can see the VLANs 10, 20, 30. And then next is a configuration of the physical ports, right? For the core switch, G01, that's it. G01 is connected with the access switch. G02 is connected with the AC. So both of them are trunk ports. So the configuration is here: switch mode trunk, switch port mode trunk. Okay, and next. Next, since the core switch serves as the gateway, okay, serves as a gateway. So I'm creating the SVI, interface VLAN 10, interface VLAN 20, and configure the IP address. Okay. Okay, you can see here, I forgot to create VLAN 40. So here is a notice: VLAN 40 does not exist, right? You can see here by usage. Sorry. All right, please wait a moment. Some further course to my PowerPoint. Okay. Okay, let's see. After finishing the configuration, you can see by using shoe VLAN, by using the command shoe VLAN, we can see we have created, sorry, VLANs 10, 20, 30, 40, right? And let's see it. Sorry for that. Okay, let's go. This AC. Okay, let's see here. After finishing the configuration of the core switch, you can see we have VLAN 10, VLAN 20, 30, and 40. And for these VLANs, the IP address of their SVI interface is showing here. Okay, and then after finishing the configuration of the core switch, next, let's go. Now we're switching to the access switch. We change the name to be ACC-SW, so access switch, right? Here we create a VLAN 10, VLAN 20, VLAN 30. And we're configuring the physical ports to be trunk. And interface G03. Here, G03 is a port. Let's just stop it. G03 is a port connected with the AP on the left. G04 is a port connected with the AP on the right. Okay, so both of them are trunk, and we should, since all the APs belongs to VLAN 30, so we should change the native VLAN of these two ports to be 30. So you can see the configuration of these two physical ports. We have 10, 20, and 30, right? And then next, let's go. Now we are switching to another device. Right? This is the AC, hostname AC, right? And then let's see what we should do on AC. We should create a VLAN 10, actually VLAN 10, 20, and 40. Let's see it. Okay, and through VLAN, you can see we create VLAN 10, 20, and 40. And since the WLAN 40 is the interconnection IP, right, or interconnection WLAN between AC and AP. So we should configure IP address of WLAN 40. You can see the IP address 192.168.30.40.2. And we should create a loopback interface. The IP address is 1.1.1.1.32. You can see the IP address, right? And here we do a pin test. Let's see, will it work or not? Pay attention here. Here you can find is the unreachable. It's unreachable. Why? Since 41 is directly connected with 42, but why it's unreachable? You should think about the reason. Actually, because we didn't configure the physical interface G02 to be a trunk port. So the traffic from WLAN 40 is not allowed actually. You can see here I'm modifying the configuration. And here, after modifying the configuration, you can find it's reachable right now. It represents that we have finished the configuration, the basic configuration on all three devices. Okay, so this is about the basic configuration. And next, let's go. After finishing the basic configuration, next is the configuration of DHCP. Okay, on the core switch, we should create 3 DHCP ports. Employee, which subnet is 192.168.10, gateway is 10.254. Guest belongs to WLAN 20, so here the subnet is 20.0, and the gateway is 20.254. For the AP is WLAN 30, so 192.168.30.0/24, and the gateway is 30.254. And the last but not least is the option. Option 138 is 1.1.1.1. And actually it's the IP address of the loopback 0 on AC, right? This is what we should configure. And next, let's see how to do that. The configuration IP DHCP port, employee, network, subnet, and mask. Next is the gateway, default router, right? And the DNS server 8.8.8.8. Okay, now we have finished the configuration of the first DHCP port, which name is employee. Next is the guest. Okay, and then last one. Here, pay attention. For the DHCP port of the APs, we should configure the option, right? Option 138, IP 1.1.1.1. This is very, very important. And you can use show IP DHCP port to check the status of each port. And you can find that for the port which name is employee, we have 253 IP, but no IP address is distributed. For the guest is the same because there is no AC, sorry, there is no STAs. So no one will get the IP address from these 2 ports. But for the DHCP port, which name is AP. You can see 2 of them is distributed, means 2 APs has got the IP address. So let's check. Use the command show IP DHCP binding. You can see AP has got 2 IP, right? 30.3, 30.4 is assigned with a device MAC showing here. It's a MAC address of 2 APs in the network, actually. Okay, so this is about the configuration of DHCP port. And next, since until now, the APs has got the IP, so they have got the IP address of AC. But on the AC, what we should do is to assign or is to cure the AC that we use the IP address 1.1.1.1 to establish the kappa terminal. So let's see the configuration on the AC. First, the AC controller means we're configuring the parameters of AC. Cap-web, you can see the command. Cap-web CTRL. CTRL means control. Actually, control IP is 1.1.1.1. Okay, this is the command to specify the source IP address of the cap-web terminal. And then let's see, we can use a command show cap-web state. Show cap-web state to check the status of the cap-web. Okay, you can find that by using command show cap-web state. There is no cap-web state, or there is no cap-web terminals at all. Here we should think about the reason why there is no cap-web. Because now AP knows the IP address of AC, and AC has specified the IP address for cap-web. So normally they should establish a cap-web terminal. But now by using the command show cap-web state, we find there's no, right? There's no cap-web. So the reason, maybe the reason is that AP and AC cannot communicate with each other because the AP and AC are in different subnets. Pay attention here. The AC's IP is 1.1.1.1, and the AP's address, if you still remember, is 192.168.30.3 and .4. They are in different subnets, so there must be the root. Okay, so let's see what we should do. Let's do a ping test. Do a ping test. Ping 30.3, source 1.1.1.1, and you can find it's unreachable, right? So here we are configuring the static route on AC. And except the configured on AC, we should also configure the static route on the core switch. So we switch to the core switch. Okay, you can see it, right? And after finishing the configuration of static routes, you can see now we use the show cap-web state. You can see we have 2 cap-web terminals, and the peer IP, one of the peer IP is 30.3, the other is 30.4, right? 30.3, 30.4, and the state, both of the state is wrong. Wrong means the cap-web terminal has established successfully. Okay, so means the cap-web terminal is established successfully. Okay, and here I see since we're on live on the Facebook, and I see a question from the from the Facebook, it says that do the trunk mode need to set the access list. See, actually, I'm not sure what's the access list. I'm not sure if you means that during the configuration of the trunk, do we need to configure the allow path list, right? Because for the trunk ports, there is a concept called allow path list to specify which VLANs is allowed to go through the trunk link. And on the reject devices, it's not necessary. Actually, it's not necessary because if you set one of the port to be the trunk, by default, the system will automatically allow all the VLANs. Allow all the VLANs has already created to go through. For example, we have created VLAN 1, VLAN 20, VLAN 30, VLAN 40. So by default, this VLANs is allowed. Okay, so it's not necessary. It's not necessary. Yeah, I know you mean the access list is to allow the VLAN traffic, right? Okay. Okay, this is a question for the trunk port is on the reject device. It's not necessary to configure no matter the allow path list or the access list. Okay, because by default the VLANs are allowed. Only when you want to maybe disallow, right? Disallow some of the VLANs, you can maybe delete some of the VLANs from the default allow path list. Okay. Okay, you got it, right? Then let's go. Then is the basic configuration of WLAN. Basic configuration of WLAN means we should create the WLAN, set the SSID, bind the SSID with the how can I say, with the VLAN, right? With the specific VLAN. For example, SSID employee is bind with VLAN 10, guest is bind with VLAN 20, and the AP group is we just use default AP group. Let's see the configuration. It's quite simple. WLAN config 1 employee means we have created a WLAN 1, which SSID is employee. And WLAN config 2 guest means WLAN 2 SSID is guest. Next, AP group default. Interface mapping 1, 10 means WLAN 1 is mapping with VLAN 10, and interface mapping 2, 20. So WLAN 2 belongs to VLAN 20. Okay, so this is the basic configuration of WLAN, right? And after finishing this, you can use your laptop or use your mobile to test. If you can search the two signals. First, the SSID is employee, and the second SSID is guest. If you can, means the configuration succeed. Okay. So let's see it. Here, I use my laptop to check. Okay, you can see two signals, employee and guest. Since there is no lock, you can see there is no lock on this icon, so it means they are open because we didn't configure the authentication anymore, right? Okay, so this is the how to verify, right? How to verify the configuration of this state. So since they are open, so we think they're not secure, right? Not secure. So for the network which SSID is employee, what we use here is a PSK. Okay, because of the limitation of the network device, actually, or to obviously see the results. Here we use is the WPA2 PSK authentication for the employee. Okay, for the employee, and the password is region at 123. So let's see how to configure it. First, they see the configuration. WLAN sec 1 means we are configuring the security for WLAN 1. Okay, for WLAN 1. And the commands security RSN enable is to enable the encryption of WLAN. And the security RSN cipher AES enable means here we use the algorithm AES to encrypt. Okay, and next security RSN AKM PSK enable means we use the pre-shared key here, and the pre-shared key is the region at 123. So until now we have finished the configuration of the how can I say, of the authentication. Okay, that's it. That's a configuration of the pre-shared key. WPA2 pre-shared key is quite easy, right? Quite easy to understand. So to accept that, or except the authentication can strengthen the security of the network, we can still use user isolation. We can still use a blacklist to improve the security. So here for the user isolation, what we use is the AC SSID based isolation. Okay, and for the blacklist, you can see we should add a blacklist, which MAC address is here, and we just use this blacklist for SSID employee. Actually, this MAC address is the MAC address of my mobile, okay, of my own mobile, and later we're going to verify it by using my mobile. So let's see it. Firstly, let's see the configuration. WIDS means we have entered the WIDS configuration mode, and user isolation. You can see here, user isolation have different modes. By using the question mark, we can see the optional modes here are AC, AP, SSID AC, SSID AP, and the WLAN ID. WLAN ID means to a specific WLAN by using the ID, which, for example, WLAN 1, WLAN 2. Okay. And let's see what we use here. User isolation SSID AC. Enable. So we have enabled user isolation based on SSID and AC. And here I configured another command. You can see user isolation SSID AP enable. And after press enter, it takes effect. So the reason why I do it here is to show you that for the user isolation, we can use more than one mode, or we can use multiple modes at the same time. For example, we can use user isolation AP enable, user isolation AC enable, or even we can use all of them at the same time. Okay. You should know this, and you can choose some of them in your network based on your requirements. After finishing the user isolation, next let's see. Next is the blacklist. Since we should enable this blacklist only for employee, so SSID filter blacklist means this is SSID based blacklist. MAC address A47. Okay, so here is what we have done, right? This first is the configuration of user isolation and then the configuration of the blacklist. So in this way, the device with this MAC address cannot access the network anymore, and the users are isolated based on the SSID and AP, SSID and AC. After doing this, next what we should do is to verify the results, right? Verify the results. But since since it's very difficult to verify the configuration of user isolation, okay, or it's very difficult to show you the verification of the user isolation. So let's just see the verification of the blacklist. let's see. Now I'm using my mobile to connect with the, firstly connecting with the, you can see, connecting with the Wi-Fi, which name is guest, And here you can see my IP address is 192.168.20.1. So means now guest is open and I have successfully connect to the guest. And I got the correct IP address because we say that the guest belongs to the subnet 192.168.20.1, right? And the next, I would try to connect with employee. Pay attention. Since I'm connecting with employee and we have configured the PSK authentication, so you can see which we are required to enter the password here. No, I'm entering the password. 瑞杰@123. And pay attention. Let's get back. Pay attention here. For the mobiles, you can see for the mobiles, some of the mobiles support the how can I say, random MAC address. There is a function called random MAC address. For example, each time when I access the wireless network, I will use a random MAC, while it's not the physical MAC address of this mobile. So if we want to verify the configuration of blacklist, here you should manually set to be used. You can say here, use device MAC. Since device MAC is unchanged, so only in this way we can maybe verify the results. And let's see what would happen. Since I have added the MAC address of my mobile to the blacklist, so you can see when I try to connect, there is an alarm says that denied access to network because I'm in the blacklist, right? I'm in the blacklist. So connection failed. While for the mobiles that are not in the blacklist, they can normally access the employee, right, and access the internet. Okay, so this is the process of finishing this configuration. Okay, and actually in this lab we have covered the configuration of all the configuration of RCNA WLAN. So if you can finish this lab, means you have mastered the configuration of we should know in RCNA WLAN. And even this topology is simple, it's not that complex. But for the large networks, it's similar. For example, to cover a large area, we just need to add some switches. We just need to add some APs, but the configuration is the same. Okay, so you don't think that this board is too simple, so it's not important. Actually, it's quite important, right? If you can finish the configuration of it, you can maybe install or you can deploy a large WLAN network by yourself. Okay. Okay, so this is about the content we want to introduce today. And about what we have mentioned today, maybe do you have any questions that we can maybe discuss here? Do you have any questions, or do you have anything you want to share with us? Okay, since if you don't have any questions, so let's just make a summary and okay, let's see. Yeah, team, what's your question? is there a way to bind an AP to a device? I don't get, actually I don't get what you mean. Why do you need to bind the AP with the device? You want to bind the AP with terminal device or a network device? For example, I want my printer to log to an access point. Okay, let me think about it. For example, I want to, but I have many APs. Sometimes it connects to other APs. Okay. Bind. But I want to connect this printer to only nearest AP. Okay, firstly, I think the reason why the printer would connect with other APs maybe because other APs can offer better quality of service, right? So so I'm not sure if it's necessary to do that, and I will check it. Okay, I will confirm it later to know if there is a function to bind an AP with bind an AP with different our AP has different VLAN. Okay, for example, there is a method to do that. You can check the MAC address of this printer and add the MAC address of this printer to the blacklist on all the other APs. Right? Is this a method? Let me see. Blacklist. No. Sorry, it cannot serve because blacklist is related to the SSID, right? Okay, maybe can you give me your email address, and later I will confirm. Okay, I will confirm it. Of course, now I cannot come up with any solutions to this problem, and I will confirm it and give you a feedback to your email. Okay, and I will confirm it. APs. Yeah, can you please privately send me your email address so I can maybe get in touch with you. Okay, I have sent you a private message, and please give me your email address. Okay, how about others? Do you have any questions? Okay, if you don't have any questions, so that's all for this, and we would like to know which another device. Fortinet. No, ours is always another device. Okay, if you want to make know maybe how does it work with maybe other devices, we will have certifications on this training, sir. We have RCNA WLAN certification. we have RCNA WLAN certification, and if you have finished the learning of this course, you can maybe have a try to get that certificates. Okay. Okay, about the question RSSO, can you maybe give me some detailed information? I cannot exactly understand what you mean. Hello, is here? Would like to know RSSO with another device. So can you maybe give me more information about the we send information from Fortinet. Is this sorry, is this a problem of your network, right? Is this a problem of your network? Maybe if it's a problem of the network, and you can maybe ask our tech team for some help. Of course, here actually is a public training, so we're not solving the real problems in the network. Okay, or if you like, you can contact me after this training, and we can discuss it together. Okay, no problem. Okay, then since we have finished the content today, so let's see the satisfaction questionnaire. You can scan these codes, and maybe you can evaluate our training this time. Okay, so if you have finished the questionnaire, so you can leave the conference now. Thank you for your time. Thank you for your help in this training. Okay, and hope to see you again in the public training next month.